So this is the GUI developed for image watermarking using iris images as a digital watermark. So the iris image will be acquired and processed to form a digital watermark, and the watermark will be embedded in an image and extracted under signal processing attacks and will be identified from the database. So you can see this is the module which is the biometric watermark generation. The image will be processed to form a watermark over here. The next module is the embedding part, where you can see this module will be responsible for embedding the watermark in the image. The third module is the extraction module, where the watermark will be extracted from the embedded image, and there is option for applying different attacks, which you can see here, and if there are different options to see the bit error rate and that normalized correlation over here. And the last module in this GUI is the identification of watermark, where the recovered watermark will be subject to identification with a database of different templates. So here we go. So this is the watermark generator. When we click this icon, there's an option for choosing an image from the database. So let's say I go to this database and I pick, let's say I pick the 25th sample. This is the one is the left eye, and I pick the first sample of the left eye. So you can see the left eye is it's processing over here. It's processing, and you can see this is the eye, and the watermark is generated. Now let's say this is the biometric watermark, which you can see. This is the you can see a binary pattern which is generated over here, and this will be used as the watermark. Let's see how the pause spectral density of the watermark look like. So this is the normalized frequency in the x-axis with the pause spectral magnitude on the y-axis. You can see there's a uniform distribution of the pause spectral density of this watermark, which indicates that the spectrum is equally loaded on the entire frequency range. Since this is a normalized frequency, it is divided by the maximum frequency, and hence the maximum value is 1. We can see here that the higher frequency size and the lower frequency size are equal distribution of the spectrum, which indicates that filtering operation and other operations may not be responsible for completely removing the watermark from the signal. And this is an option which will give you the size to calculate the size of the watermark bits. If you click here, you can see 9600 is the size of this watermark generated, which indicates that 9600 bits are available in this particular watermark. So this module is responsible for watermark embedding. Let's say this will give you an option for choosing a host image. Once we click over here, it will take you to the database. Let's say I take a host image. Let's say I take standard image of Lena over here. So this Lena is the host image in which the watermark will be embedded. Let's say I click the watermark embedder in this over here. So the process of watermark embedding is taking place in the background, and you can see this status bar will give you an indication whether the watermark is embedded or not. Once the watermark is embedded, the status bar will come. Okay, so you can see as the status bar moves towards the end, the watermark is actually embedded in the image. So here we go, and well, now you can see the watermark has been embedded, and this message has been displayed that watermark is embedded in the first image. We say it's okay. Now we can see the watermark over here, and you can see there's an option to see the original and the watermarked images separately. So let's say you can see over here, this is the so this is the original image, and this is the watermark image, which you can see, and the quality of this original image and the watermark image seems to be almost similar. So perceptually there is no tampering, and the perceptual transparency of both the images seems to be very nice. So the first requirement of watermarking is maintained, that the image has not lost its perceptual transparency. Let's see what is the signal to noise ratio over here. There is a option over here. You can see if you click this button, it will return the signal to noise ratio in terms of decibels. So you can see 34.69 is 34.69 dB is the PSNR, the peak signal to noise ratio, which is decently good enough, because normally the literature says that anything a signal to noise ratio above 25 dB should be good enough, and 34 should be decently good enough. This option gives you an opportunity to see the payload that is applicable. Let's see what is it like. 109.227, which indicates that one bit of watermark is actually hidden by 109.22 samples of the image, which is a decently good enough watermarking payload. So you can see a good enough watermarking payload has been achieved, and perceptual transparency is maintained with a good enough amount of PSNR over here. Now look at this module. This is the module where the watermark can be extracted. Here there is an option of applying an attack. So you can see when there's an option of applying an attack, let's say we apply an attack over here. Let's say we go for median filtering is one of the common attacks which is applied. When we say when we go to median filtering and apply an attack. Now this is the watermark image which was developed, which was generated in the previous step. So we select this, and median filter attack is applied on the watermark, which we can see over here, right? And this message is displayed, which indicating that the attack is already applied. Now this option will give you that you see the attack image. Let's see, yes, the quality of the image you can see is almost nicely maintained, so it's not a problem at all. So you can see that's the median filtering image where the quality of the image is, and we would like to generate extract the watermark from here. Okay, so this is the watermark extractor. We go over here and let's see. So the attack image, which is that, so this is the watermark. So this is the attack image. Okay, so the attacked image is processed for recovering the watermark. Let's see how it goes. Okay, so let's see how it goes. So it takes a while to recover the watermark, because the algorithm is running over the entire image, and block by block it is trying to generate and recover the watermark from the attack image. Does it come to the end of this call bar? Let's see. Okay, so this message says that the watermark is extracted, so it's nice. Let's see what is the BER, the bit error rate percentage. Let's see. So it's calculating 0.125. It's fairly low bit error rate, which you can say that the accuracy of the extraction was very nice. Let's see the correlation part. The normalized correlation is 0.995. So even please understand that let's say even under a serious image processing attack like median filtering, we are in a position to get a good amount of accuracy in terms of extraction of the watermark, where the bit error rate is 0.125 and the normalized correlation is 0.9975. Now let's see if we can actually go here and run the identification of that. So this is the image. This is the template. This is the recovered watermark. So after the identification is under progress as per this status bar, and let's see if it is in a position to match the image, match the recovered watermark to some template in the database. So let's see how it goes. So identification is done. So it says identification is done. So I say it's okay, and show the identification curve. So there will be a generation of the identifying curve, and you can see here, very interesting, that it's matched to the iris sample of 25, and there is a very long spike at the sample number 25, which you can see over here. So initially we had selected the 25 number sample of this image, and you can see finally that extracted the image was transformed into watermark, embedded into this signal and recovered under an attack condition, and the identification curve shows that this matched with the 25th sample. So this is interesting. So this GUI gives you a provision of looking into a text display which indicates that it has matched with the sample of the database, and this high correlation peak at the 25th sample indicates a distinct and accurate identification of the extracted watermark. And that's all.